In the previous step, risks are identified using HARA. If you haven't seen that yet, you can check out our video on HARA for a detailed explanation. But once the risks are known, an important question remains. What do engineers actually do with these risks? How do they translate them into something that can be implemented in a system? This is where safety goals come into play. Safety goals are one of the most important elements in ISO 26262. They define how a system must behave to remain safe. In this video, we explain what safety goals are, how they are derived from HARA, and how they guide the entire development process. Let's start with a simple question. What exactly is a safety goal? Once risks have been identified through HARA, the next step is to translate them into something actionable. And this is exactly the role of safety goals. Safety goals define how a system must behave in order to remain safe. They are not just abstract ideas. They directly guide how systems are designed, how they are verified, and how safety mechanisms are implemented. In other words, safety goals connect risk analysis with real engineering decisions, and this is important. If safety goals are defined incorrectly, the system may either be unsafe or unnecessarily complex and inefficient. So now the question is, what exactly is a safety goal? A safety goal is a high-level safety objective that is derived from a hazardous event. It defines how the system must behave in order to remain safe in a critical situation. For example, instead of describing a failure, a safety goal defines the desired safe behavior. And this is important. Safety goals are independent of how the system is implemented. They do not describe technical solutions. Instead, they describe what must be achieved from a safety perspective. These goals then serve as the foundation for all further requirements in the system. Safety goals are not defined in isolation. They are directly derived from the results of HARA. If you have seen our previous video on HARA, you already know that hazardous events are identified and evaluated based on severity, exposure, and controllability. Based on this evaluation, engineers determine how critical a situation is. The next step is to define a safety goal that addresses this risk. In simple terms, safety goals describe how the system must behave to prevent or control the hazard. So this step transforms risk analysis into clear safety objectives. So what makes a good safety goal? A good safety goal clearly defines the intended safe behavior of the system. It focuses on what must be achieved, not how it is implemented. Let's look at a simple comparison. A weak safety goal might say something like, avoid malfunction. But this is vague and not actionable. A strong safety goal, on the other hand, clearly describes the expected behavior. For example, preventing unintended braking at high speed. So here is a simple question. Which of these would you be able to verify in a real project? The answer is clear. A good safety goal must be precise, unambiguous, and linked to a specific hazardous event. Safety goals are always linked to an ASIL level. This ASIL is inherited from the hazardous event identified during HARA. So the level of risk directly determines how strict the safety goal must be. A higher ASIL means stricter requirements, more robust design, and more extensive verification. This ensures that critical risks are addressed with the appropriate level of rigor. So here's a key takeaway. Safety goals are not just statements. They carry a defined safety integrity level that influences the entire development process. Once safety goals have been defined, they need to be translated into detailed requirements. At the next level, engineers define functional requirements. These describe what the system must do in order to achieve the safety goal. From there, technical requirements are derived. These describe how the system will be implemented in practice. Finally, these requirements are allocated to different parts of the system. For example, software, hardware, or system components. And throughout this process, traceability is essential. Every requirement must be traceable back to the original safety goal. Let's look at a simple example. Consider unintended braking behavior. This is our hazard. Now define the situation. The vehicle is driving at high speed on a highway. If unintended braking occurs in this situation, the vehicle may decelerate unexpectedly. This creates a hazardous event. Now the question is, what should the system do to remain safe? This is where the safety goal comes in. A suitable safety goal would be to ensure controlled braking behavior and to prevent loss of vehicle control. So instead of describing the problem, the safety goal defines the desired safe outcome. There are several common mistakes when defining safety goals. Let's go through the most important ones. First, defining goals that are too vague. Statements like, "The system should be safe," are not useful. Second, mixing safety goals with technical solutions. Safety goals should describe what must be achieved, not how it is implemented. Third, not linking safety goals to specific hazardous events. Without this connection, the safety goal loses its meaning. And finally, missing clear and verifiable behavior. A good safety goal must be precise and testable. Let's summarize the key points. Safety goals define how a system must behave in order to remain safe. They are derived from hazardous events identified during HARA. Each safety goal is linked to an ASIL level, which defines the required safety rigor. These goals are then translated into requirements and guide system design and implementation. And this is why safety goals are a fundamental element of functional safety.